In this demo, we're going to show you how you can use the Torus toolkit to easily move to a Docker-based workflow for your machine learning projects. The advantage of using Torus and Docker is that new environments can be spun up super fast with no hassle with regards to package installation and configuration nightmares. Also, Torus and Docker guarantees that the dev environments across your team will be consistent and repeatable, which will avoid many headaches further down the road in the dev cycle. On the right side of the screen, you can see the cookiecutter-data-science repository that Manifold forked from a project originally written by Peter Bull. Most of the project layout is the same, except we've added some configuration files and scripts to make this an easily Dockerizable project. On the left side here, I have my terminal open, and I'm going to start a brand new project from scratch using this version of the cookie cutter. The cookie cutter will provide a few prompts to initialize the project. You will need to supply a project name, repository name, description, the name of an S3 bucket to store data, which is optional, and the name of an AWS command line profile to use, which is also optional. Within a few seconds, your new project is completely scaffolded out for you, and there is a post-generation message here letting you know that you're ready to run the start script. If we look at the Docker file, we'll see that it contains a single line, which is an instruction to build this project's specific Docker image using the Manifold Torus base image located in the Docker Hub. Let's run the start script to build our image and start working inside of our container. The base Torus image is downloaded from Docker Hub, and a new container is launched with this image. If this is the first time you're using Torus, you'll need to pull the full image from Docker Hub, which takes a few minutes. For the sake of this video, I'm going to fast forward this part here just to keep it moving. We can use the Docker command line tools to see that the launch container is running, or alternatively, we can use an app called Kymatic, which is a graphical user interface which makes it really easy to work with your containers locally. If you're using Docker for Mac, you can easily access the Kymatic app from the Docker menu in the minibar. It's a great app to use if you're new to Docker because you can hit the ground running without having to learn a lot of the Docker CLI syntax. In the top left here, we can see that our demo dev container is running, and it is already running a notebook server that's ready for use. We can launch a browser tab right from this app to start working with our Jupyter notebooks. Let's go ahead and create our first notebook using Python 3, which is the version of Python that's already installed in the Torus base image. There are many commonly used Python data science, machine learning, and plotting libraries already installed in the Torus image so that you can hit the ground running right away. Let's go ahead and drop in a Hello World example using matplotlib and NumPy and run it. As you can see, this environment is already configured to draw charts in your notebook, and at no point do we have to do any package installation or system configuration. So working in a notebook is great, but there comes a time when you need to start pulling your code out into Python modules or other scripts. The Torus setup makes it easy for you to use your code editors in your host machine while still benefiting from a pre-configured and isolated runtime environment in the container. This is made possible by leveraging Docker's shared volume feature, which Torus configured for you when you ran the start script. So let's see a quick example of how the shared volume works. By default, the top level of your project directory is mounted to /mount inside of the container. The Jupyter server in the container is run from this directory, so it can see all of your project files like we see here. The project files also exist on your host machine, so IDEs like PyCharm can also be used to modify your code. We can see that the project structure in PyCharm exactly matches what we see in Jupyter because they're actually the same files. Let's go ahead and edit the start script as an example. I saved these changes on my host machine, and if we look back at Jupyter, we can see that the last modified time for the start script has been updated. If we open the start script in Jupyter, we can immediately see that the changes we made from PyCharm are there. This setup allows engineers to continue to use IDEs locally while leveraging the guaranteed consistency of a runtime environment in the Torus container. In less than 5 minutes, we were able to go from cold steel to a fully functional development setup running inside of a Docker container. This is just the beginning, as we have many new tools that we're currently working on and will be adding to the Torus toolkit in the very near future. We hope this initial release will help you move your projects to a Docker workflow so you can reap the many benefits of containerization in the dev lifecycle. Thanks for watching.